Howdy. That's Texan for hello. My name is Dave Josephsen. And I'm here today to give you a talk about spam. Who am I? Like I said, name is Dave. I wrote a book about Nagios. My publisher actually sent along an copy for me to hand out to you today. I write the monitoring column for Login Magazine. Otherwise, I'm pretty much just a straight sysadmin. I'm not the CEO of anything. I mow my own lawn, pretty much. So I'm not here to sell you anything or anything like that. I'm here mostly because I have a bone to pick, quite honestly. But also it's therapeutic for me because I'm terrified of public speaking. So the bone I have to pick specifically is that I think we as a systems administration community is incentivizing the spammer community to attack the network layer. I'd like us to stop in no uncertain terms. And so I'm giving you a presentation based on really, I'm going to give you some context on the spam war thus far. I know that's kind of boring. But if you'll bear with me for a few moments, I think I can tie it all together and make a pretty good case for why we should stop doing what we're doing and do something else. What I've done in this talk is I've separated spam tools into two primary categories. I'm basically lumping everything, and this is argue, I'm lumping everything that doesn't look at the actual content of a message. And I'm calling those delivery countermeasures. And so these are solutions that are looking at IP address, presence or absence of header, keyword in the subject line, things like this. So gray listing, RBLs, pretty much anything that isn't content filtering is going into the delivery countermeasure bucket. And everything that is content delivery, or everything that is content filtering, I'm calling content filtering. So the bottom line, this is a timeline. The bottom line is, and I realize you can't read this. It's not really important for you to actually read the labels. I think I'm just trying to give you some context here when I'm trying to talk about. The bottom line, the one in blue, is pretty much every content delivery countermeasure, every delivery countermeasure that we've come up with over the last decade or so, give or take. The top line, the green line, is the content filtering, and the middle line is the spammer's response. So I'm starting way back in 1978 with Gary Thurek. I know there was a spam talk before me, and I missed just about all of it except for the comments. So if you guys are already bored with the history of spam, just let me know. But some of this stuff is actually really interesting, and it bears mentioning in the context of the overall situation that we find ourselves in. It starts basically in 1978 with a DEC representative by the name of Gary Thurek. It actually starts a little bit earlier than that. There's an RFC, I don't know if any of you know, I think it's 706, I'm not sure. But it's 1975, and they're talking about the concept of spam, and they're not calling it spam yet, but they're saying, this could be a problem. Gary Thurek in 1978 spams ARPANET with a DEC 20, I think it was, message. The point was Gary was an East Coast guy, and he had lots of contacts on the East Coast, and he wanted to introduce himself to the West Coast people, so he wanted to have a couple demos. So he decided since ARPANET, or since the DEC 20 was going to integrate ARPANET support, that what he would do is he would send a ARPANET message to everyone on the West Coast who had an ARPANET address. There was a hard copy list of addresses at the time. And so this is what he does. He actually gets together with a systems engineer who didn't know how to use the mail program and crafts this message, which is hilarious. It's still out there. You can look at it. The engineer actually starts in the subject line, starts typing in addresses, overruns the subject line, goes into the to line, overruns the to line, goes into the CC line, overruns the CC line, and goes into the body of the message. And so you have this sort of wonderful faux pas that a lot of people talked about at the time, and censorship was brought up. And you have this really great sort of email thread that goes back and forth between the people, which includes RMS, by the way, who's all for spam. And if chicks are involved, or any sort of dating service at all, he's down. Just stop sending him your baby messages or whatever. It's good stuff. You should read it. It's if you haven't. I assume probably most of the people in this room have. But from there, we sort of jump forward in the days following poor Mr. Thurrock. The response to those types of messages was pretty severe and pretty quick. There are a few things that happened between 78 and around 94, some anti-war messages, some peace messages, some God messages, things of those nature, but nothing really that equals what Cantor and Siegel, a pair of lawyers, did in 94 when they send out the spam that was heard around the world, as you probably all know, called the green card spam. And it was an advertisement for the green card lottery, the United States green card lottery. They were eventually disbarred. They were very happy with what they had done, despite the public outcry. And they were eventually disbarred for it. Lawyers so despicable that other lawyers didn't want them to be lawyers anymore. And they finally faded into obscurity when people stopped paying attention to them. There was some talk of going and picketing their office and doing this sort of thing, but finally everyone just sort of started ignoring them, and that seemed to work. They wrote about a couple books that never went anywhere, kind of like my own. So anyway, where the timeline splits off, that black dot, is right where we start getting into Usenet spam and cancel moose and all of this sort of, where the internet marketing actually started getting pervasive and people actually started reacting to it in negative ways. And again, there's still a lot of concern about censorship. There are marketing groups that are formed around this at this time. The, I can't remember what the name of them, the Soldiers for Freedom or something like this they call themselves. Anyone? So right about now you have two basic sort of technical responses as pertains to getting spam. One of the very first example of content filtering was Nancy McCullough's proc mail filtering FAQ, which appears somewhere around 95, early 95, late 94. You also sort of at the same time get this other community which involves the cancel moose and UDP cancel messages in general. And the cancel moose, I don't know, most of you look, no offense, pretty old, so you ought to probably remember most of this. The cancel moose was sort of this enigmatic character somewhere in Northern Europe who took it upon himself, or people took it upon themselves to cancel UDP messages based on their content, or based on who they were, who the from address was or whatever. So it sort of breaks off into two camps and remains that way, in my opinion, to this day. You sort of have this, well, on the bottom, and this is why I made the slide like this. The bottom you have sort of this arms race. I mean, you go back and forth between static content filtering, where you're looking for words in the content of the message, and assigning them, oh, excuse me, I'm sorry, I went off onto the wrong fork. So down here you have, static IP domain slash, type filtering where you're, oh, this person is from, wherever.com, so I'm not going to take his message, or this, particular person, his IP is in my personal blacklist, so I'm not going to accept that. Up on the top you have static content filtering, which, as I said, is looking for, given words. We're looking for the word, I'm not going to say that word. I don't know, let's pick a different word. Yeah, I'm not going to say that word either. Well, never mind. You can use your imagination. And looking for those sorts of words in message bodies, you're assigning them points, and you're filtering the message based on that. So this bottom portion of the timeline sort of creates Joe-job attacks. And now spammers are going around in there. Now they're spammers for all intents and purposes. They have lists of addresses that they can spam you with, and they are actively trying to defeat your content filters and or delivery filters by obscuring things. They're spelling words like that with, a capital 1 instead of an I. And they're, doing things like, white HTML text and all the, nefarious kludges and hacks that we're familiar with. On the bottom, you have them doing things like just spoofing the from header and saying, I'm Dave at, whatever.com and accept my message. And that's working really, really well for them. You have, on top of, Joe job attacks, you get open relays. So now, not only are they saying there's someone else, they're sending, you mail from someone else on top of it. And sort of point for each one of these dots, you have this kind of ping pong effect. When we come up with, RBLs, they go to Joe job and open relays. When we come up with gray listing, they start sending messages multiple times. When we do, the hash cache and the e-stamps and things of this nature, they start owning boxes, really, and just kind of using other people's credentials. It's sort of a decades-long history of spammers being able to take other people's credentials, use them for their own accords, and bypass our spam mechanisms based on that. And we really haven't recovered from it as a systems administration group. We seem to be coming up with more authentication tokens for them to bypass. It concerns me a little bit, and I wouldn't really care, but now I think that it's going a little bit too far. Out here in 2004, 2005-ish, 2003, really, I started hearing rumors of this, where spammers were going out and they were using, route health injection attacks and, things of that nature, like route injection attacks, which is what we're here to talk about today, to bypass, bypass RBLs, really. This is sort of directly designed to bypass RBLs. What we're doing is we're just taking your IP address. And this, is not a good thing. I think this is a terrible, terrible thing. So I think that we should probably get away from these IP-based mechanisms, right? Because we're just sort of incentivizing them to attack the network layer to get around them. I'll get to more of that in a second. I want to make one point here at the end of SPF. This is where the free book comes in. SPF is, you guys know what SPF is, sender permitted from, or whatever they're saying it stands for this month, is the mechanism whereby you publish DNS records that say who your valid email servers are. And if you try to send me a mail from a given domain and it doesn't match the SPF record for that domain, then I'm not going to accept mail from you. Does anyone have any idea who has the largest acceptance rate of SPF? What community uses SPF the most on a daily basis, according to Sophos in 2005? Just scream it out. No? Spammers, there it is. Free book. Here, I got you. All right. Spammers love this idea. This idea is like, manna to spammers. They're like, so all I need to do is, create a domain and, register a wildcard record from my domain. It's an SPF record. And I can send you spam all day long. I love this. This is great. This is all I need to be legitimate. So a cottage industry of, domain, like domainking.com is one. Domain registration providers sort of popped up where you can now register 150 domains at a time, all with SPF records set up for them, random gobbledygook in the domain. But they think it's a great idea. And I think that this is really illustrative of the problem. I think this is where we've missed the point. What we say when what we think we're saying, we think we're making like a firewall type policy decision here. We think what we're saying, hey, you're not allowed to send me mail unless you're not on my blacklist or you're not on this RBL. And I think what the spammers are hearing is, I'm allowed to send you spam as long as I'm not on your RBL. I think that there's a dichotomy there that we're not understanding as a group. And it's probably the core of the issue, and it's very illustrative of the SPF problem. It seems like it's ironic to us, or it's at least ironic to me. It seems ironic to me that spammers would be the biggest users of SPF, but it's not at all in the context of how spammers are viewing this problem. So moving on, sorry, 2003, 2004, I got on a little bit of a digression there, but I told you before I was bad at public speaking. So 2003, 2004, this concept of prefix hijacking comes in. And it's first described, well, first place I've been able to find it described is a couple Usenet postings somewhere around 2003. There's a spam cartel book out there if you've read it that also makes reference to this attack, but doesn't really, it's sort of a gray box on the side. Excuse me, that sort of, just sort of makes mention of it and moves on. But then you have a paper from Nick Feemster, I think in 2005 from Georgia Tech. It's a wonderful paper, and I'll give you a URL to it in a second. That actually has documented proof of spammers using this technique. And so what I'm going to talk about today a little bit, okay, well, let's back up for a second, is this whole concept of delivery countermeasures versus content management, where it's taking us, why I think we should abandon delivery countermeasures altogether. I know there's going to probably be a lot of comments after this one. But I think, by and large, just from the historical context of what we're talking about here, delivery countermeasures have made things worse for a decade. They're not taking us in the direction that we want to be going, which is getting less spam. What they're taking us in the direction of is zombied PC and short-lived BGP prefix hijacking. It's a bad thing. So, what is a prefix hijack? A lot of you probably know what BGP is. So you have a whole bunch of, you have the internet, and within the internet you have a whole bunch of autonomous systems, and these are, for all intents and purposes, organizations that have some sort of internet presence. They don't want to have control over each other, or at least don't want other people to control them, so they use an exterior border gateway protocol. So what this means is sort of as opposed to an interior gateway protocol like OSPF or RIP or anything like that, you have a lot more, you have a lot less control over what the routing protocol is going to do for you. You have AS prepend and you have some BGP extensions that allow you to influence the protocol and tell the protocol, give it advice as to, where your packet should be routed. But for all intents and purposes, you don't control BGP. BGP is a cooperative entity, right, between a whole bunch of people that are external to you who you don't control. So what happens is BGP never was actually, designed for bad routes to be injected. BGP is a cooperative protocol, so much like SMTP is. So what happens is that malicious parties can actually come in, inject bogus protocols, or sorry, inject bogus routes, and have them actually work for some subset of the internet. And who it's actually going to work for is hard to predict because there's other stuff going on even on top of the routing protocol that I'll get to in a second. It's a, I always forget these, link vector protocol, I believe is what they call it. So as you advertise to other routers on the internet, you give them the entire path that you're aware of as AS numbers. So you're not, it's a TCP protocol, but you're not talking about, connection-oriented type tokens, right? You're not talking about IP addresses or ports. You're talking about AS numbers, right? And these AS numbers are just like IP addresses in that they're, registered with IANA and given to you that way. Your organization is given a single AS number. That AS number corresponds to your entire net block, usually, depending on who you are. And the BGP routers keep track of ASs. So they'll have a next hop router, and they'll have a, a path of ASs, right? Sorry, they'll have a destination IP address, a next hop router, and a whole line of ASs. So if I want to get in the diagram from AS42 all the way to A, what you're going to have is on router A, you're going to have this, ACDF AS42 sort of path. And that's oversimplifying it, but for our purposes, it works. So what happens when someone injects a bogus route? Let's say I just have a router, I throw it up there, and I tell my peer router, hey, peer router, I am AS42, or I'm AS666, but I have the same net block as AS42. Well, what happens is since the new router can't actually control BGP any more than the old router can, certain hosts believe one router, certain hosts believe the other router. BGP is designed so that only one path should win for a given router. So basically, it's sort of important where you are on the internet in terms of proximity to top-level hosts when you're doing a BGP prefix attack. location, 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 right? If we did the same injection attack against sort of our tier 1 router, D, in that graphic. Can you guys see those okay? I can like play with my mouse if you want. So this host right here, if I'm basically in my diagram here, whoever gets closest to D wins, right? Because then you have a shorter path to all of those places. So in general, the BGP protocol is a little bit complex, and you can't really predict what it's going to do, but in general, the shorter path wins. There are definitely exceptions to that. But for our intent, I think that's pretty, it gets my point across. Location, location, location. So in the context of spam, right, we can talk about, you being a good net block and you sending mail all day, and then somebody who's malicious coming along and saying, I want your IP addresses. They can do that for a given portion of the internet they can. But why would they, right? Like, if you wanted to hijack some IP addresses, why wouldn't you hijack some IP addresses that weren't already being used? If you did this, then you could deliver, messages, you could bypass RBLs and use IP addresses that no one has ever seen before. And you would be believed, for all intents and purposes, probably by the whole internet, depending on how the BGP filters are set up at the tier 1s or thereabouts. You'll probably get filtered some places, but spammers are used to getting filtered some places. They don't really care. They just want a net block that's going to bypass some RBLs, and this gets them that. And it gets them a lot of that. We can talk about, I've had a lot of comments basically about the scarcity of IPv4 and how, spammers aren't really going to be using this too much because there's only so much IPv4 space you can use, right? There's an awful lot of unallocated IPv4 space that you can use. This is, I don't know if you guys are familiar with XKCD, it's one of my very favorite webcomics. But what you see here is a map of the internet. This is actually a fractal. It's called the Heimdall curve. And what he's doing is he's mapping out the internet in terms of class A's. And the Heimdall curve actually keeps like net blocks clustered into similar areas, right? So as it's a fractal, we could actually zoom in on this and go all the way down into like a 1010 net block if we wanted to, or come all the way back out. The green areas that you see are unallocated space. So if you count up all those squares and sort of do the math on it, you have somewhere around 30–40% of the internet IP address space out there is unallocated. It's not used. And some of that is bogon space, right? Some of that is 1918, RFC 1918 space. Thank you. Okay. And some of it is just space that hasn't been allocated as IANA is currently set up. So there's a lot of potential there for attacks. I've done the math on this several times, and every time I do this talk, I forget the math. But you can think about it. Every single one of those blocks. Sorry. Every single one of those blocks. You're talking about a 10 to the 8th, right? It's a lot of IP address space. I think the subject line of my talk had something about never colliding in 100 years or something like that. It's a lot of space. So how do we know that this is actually happening? It sounds far-fetched, and it sounds like the people who came up with BGP would have thought of this, right? So how do we actually know that this isn't just a rumor? Again, I point you to Nick Feimster. This is a Georgia Tech. These are shamelessly stolen from a Georgia Tech presentation paper that was given, I think, in '06. And what you're seeing here is what Georgia Tech did was they have a 3-letter domain, and on their 3-letter domain they have a spam honeypot, a machine that basically just gets nothing but spam. There are no legitimate messages there, so pretty much every message this box gets is by definition spam. And what they've done is for every message they receive, they take the IP address, and then they correlate the IP address with their BGP logs, and they see if there's been any origin changes in their, from their looking glass box. And so what you're seeing here is this red dot is a BGP origin change for a given IP address. Then you see several spams that were sent to the spam sinkhole. And then you see the origin change back. And then this next graph is basically just sort of zoomed out, pretty much the same graph. So you have origin change spam, origin change back, origin spam chan, blah, blah, blah. Anyway. So the origin changes last, on average, about 7 minutes. They're enormously hard to detect because the people who would be detecting them, first of all, don't want to be really. As far as, like, I've been to, the nanogs and I've talked to people, and from what I can tell, the tier ones, the guys that are working at the tier 1 ISPs, are sort of considering this to be a temporary misconfiguration, right? And as far as they're concerned, hey, one more route is like, one more route. You know what I mean? That's like more connectivity, right? I'm like down with that. Sort of a bad attitude to be having. But that's kind of where they're going. I mean, they're really focused on connectivity. They're really focusing on mitigating worms, mitigating viruses, mitigating DDoS. They're concerned with lack of connectivity, and this to them looks like more connectivity. So they're not really paying that much attention. Secondly, if they were paying attention, it's 7 minutes long, and you're talking about, you're talking about internet service providers that are doing, hundreds and hundreds of gigabits per second on their backbone routers. There isn't an infrastructure here to detect this. There's an infrastructure for you, the systems administrator, to detect origin changes on your own IPs, right? There's like, Mohit Lad did a paper on phase a couple years ago, which is the prefix attack alert system, right? So you can get like emails if your origin changes. But there isn't a very good way for people who aren't you to detect origin changes that are not legitimate. There's actually some heuristics papers here. There was one in 2006. This was Johns Hopkins University did an excellent paper about heuristics for determining origin changes and whether they're legitimate or not. It's a good read. And it also brings up another point that I wanted to make at this point. They're also hard to detect because there's an economics layer on top of BGP that has a corresponding effect to the underlying policy, right? And this is expected, and the BGP people want this to happen. In my opinion, I think that this makes things more predictable, and I think that making them more predictable makes it exploitable. So let me back up and go into that for a second. If you are a tier 1 internet service provider, or even if you're a tier 2, if you're an internet service provider of any type, you're paying for you have two kinds of bandwidth: the bandwidth you pay for, and the bandwidth you don't. The bandwidth you pay for is called transport bandwidth. The bandwidth you don't is called peering bandwidth. And you also probably have a number of customers that are connecting to you. So as an ISP, you have an economic incentive to route over certain lines. You want to route over the lines that you're not paying for, right? You also don't want to route across customer networks to other ISPs of your level. This is called valley routing. So you don't necessarily want to go down to a customer and then back up to XO if you're Time Warner. That's probably not a good path to take because you're having quality of service issues at that point. So the BGP people want to have like this zero valley routing policy, but they also want to prefer customer networks because they don't want to have to route somewhere else they might have to pay for in order to get to a customer that's directly connected. So UCLA did a paper a few years ago that was called Determining the Resiliency of BGP something or other. That ought to be enough to Google. It's Determining the Resiliency of something. It was a Mohit Lad paper. And they actually created a mathematical policy based on the economics of zero valley routing that said basically, if you wanted to do a BGP hijack, if you wanted to actually carry out this attack, and you wanted to do the most amount of damage possible, that you would want to be a customer, a direct customer of one or more tier 1 service providers. So if I get into a level 3 facility and I'm a direct customer of level 3 and say Time Warner and a couple other tier 1s, what's going to happen is every route that I advertise to my peers is going to be preferred over peer or transport routes because I'm a customer. Given that the IP address block that I'm advertising isn't another tier 1 or another ISP, right? So when they make a decision, they have a packet for 64.x.x.x, and they make this routing decision that says, hey, where should I send this packet? The first place they're going to look is to their customers. And if they have a customer that matches that net block, they're going to send it to that customer. So this means that if you're a customer, obviously, you're going to have the greatest amount of leeway. Not only are you going to have the greatest amount of resiliency against attack, you're also going to have the greatest opportunity to attack other net blocks, right? And it's cold hard math, that worries me too. I think that the fact that you have an insecure ingrained routing protocol, right? And on top of that, an economics layer that's incentivizing the people that are in control of this routing protocol to do really predictable things with it, in general, is not really great security-wise. I think that there's definitely, even beyond this work, some potential for abuse there. Just get an uneasy feeling about it. So how do you do this? There are several ways, depending on how much damage you want to do. So if you have a lot of money, if you're a big spammer, and you have a lot of money, you can get a bunch of tier 1 bandwidth. And the way this is supposed to work is when you get your tier 1 bandwidth, you tell them what your net block is. And when you tell them what your net block is, they install a filter. And by they, I mean your ISP installs a filter, which says, in effect, hey, this is what I'm allowed to advertise to you. If I advertise anything else, just ignore me. Whether or not those filters are actually installed and installed everywhere is a problem. You can be an ISP, right, and therefore have peering with other ISPs, and therefore be trusted by other ISPs and not have to, and bypass the filters in this way. You can work at an ISP and be paid $50,000 to sort of ignore the BGP filters. And all they need, again, all they need is 7 minutes, right? You can call up your ISP and say, look, I'm having trouble, and I don't understand why. I think it might have something to do with this, policy that you have, the filtering policy on my BGP advertisements. Could you just turn that on? Turn that off for a second? Oh, I got to call you back, right? And hang up after they've changed your filters. And then just never call them back. And that'll probably work pretty well for you, depending on which ISP you're working for. And here's the thing about the tier 1s. The tier 1s all trust each other. So if you can fool one tier 1 into it, you're good. This is the same UCLA paper. They actually have a case study where you had ISP A, who was very good about using filters, and they were aggro about only accepting so many routes from a given host, right? So if they got a route they didn't expect from a host, a customer host, if they got a 10,000 routes from a host that only usually gives them 2,000, they didn't accept it. But when an origin change happened, ostensibly by accident, these are all by accident, by the way, this never happens intentionally. When they actually got an accidental misconfiguration, that same router, the one that was being all aggro about not believing anyone, took every single one of those routes. And it took every single one of those routes because one of its peer routers had been, 15 or 20 of its peer routers had been, from other ISPs, had been compromised. And those were routes that it trusted ostensibly. So people tend to think of the BGP problem in terms of this singular entity, and we have all these redundant paths to all these redundant networks, and it's all, there's just no way that misconfigurations can bring down the system. And the reality, I think, is a lot different. The reality is that you have an enormously complex system that has lots of redundant links, but most of them probably aren't going to be used because of the economic policy I alluded to earlier. And also, you have humans, and when humans are involved, yeah. So, well, I guess I stole my own thunder on that slide. To bring this all into context, what we have here is a whole bunch of systems administrators who are using these IP-based content delivery filters. And we're saying, based on your IP address, you're not allowed to do X. And you have a routing protocol that controls where these IP addresses originate, which is egregiously insecure, has all kinds of potential for abuse. And an enemy who has not only shown a willingness to go here, he's shown an aptitude for it. This enemy is very, very good at this by now. He's done it for a decade. And he has absolutely no qualms with going there. In fact, he's reading into your filters permission to play, right? I mean, he's saying, you know, based on your policy, I'm allowed to do X given that I meet the following criteria. So I'm just going to meet that following criteria and we'll be happy. This is bad news. And I really implore you to stop using delivery countermeasures as quickly as you can. I think that content filtering is a much better social contract. I think that when you're using a content filter, what you're actually saying to a spammer is, yeah, you can give me anything you want. I'm going to drop it in the trash if I don't like the content of your message. And that's more or less arguably so for whatever content filtering we're talking about. Personally, I really like the naive Bayesian classifiers. I think they do a wonderful job. My paper in 2004 or our paper, excuse me, Jeremy's paper and I that won 2004's Best Paper Award was about the implementation of content filters. And I would really like us to start using more of them. So I'm terrified of what's going to happen if we don't. So questions, comments, points of clarification?
The obvious first thing is that there is a database that tracks where routes are supposed to be originated.
Right. So you have the maps RBL.
The router memories, if you ever sit and watch BGP debug on a core piece of hardware, the amount of route updates that go through, it's simply not possible to get the processing power into the core switches to track all of that at this time. That being said, most of the tier ones you're talking about are doing it offline on other systems and then pushing the results of those filters into their main systems. You kind of make this thing about, you know, anybody can do this. I would love to see spammers resorting to just this. I disagree with you all entirely, because if an ISP is doing this, it's going to be fairly easy to track down which ISP is doing this. And there's a limited number of ISPs. It's not like chasing botnets. I mean, the number of people who have peering connections that are not filtered is a much, much more limited audience. I mean, you're talking about the number of people in this room. I would love to reduce the spam problem to that small of an amount. That would be great. So I kind of disagree with that entire theory.
Okay. I do make a lot of bones about the BGP attack. And I want to make it clear, the intent of the talk, the intent of this talk, is to try to move us a little bit away from these off-the-cuff sort of delivery countermeasures that are incentivizing our enemy to get around them. I don't like using these incidental indicators, and I think that they're a problem. That having been said, about BGP attacks in general, I think that this is probably not going to be a very highly used attack, and I should have said this, I'm sorry, because I think that they're probably going to want to keep this under the radar as much as possible. I think that the fact that this is happening and the fact that the tier ones that I've talked to are ignoring it is really good mojo for them. And I think they'd like to continue that. But as far as ease of use, I've heard rumors that there are literally VPS hosts that you can buy in China and Russia. VPS providers, virtual private hosts, like Xen-based or UML-based systems that you can use to actually do, BGP route injection with. I mean, all the tools, installed for you, ready to go. It really just kind of depends on how much damage you want to do, who your target audience is, and how much money you have. Yeah, absolutely.
If that's the case, let's find the AS that's doing that, because it's very easy for us to drop any route that comes out with that AS prefix. That's a trivial thing to do.
See, that's what a lot of people say, but you have, the Johns Hopkins paper in 2006 said that you have 10,000 Valley advertisements happening every day. New ones. These aren't, reoccurring, just Valley advertisements. These are new Valley advertisements that are happening in a routing protocol that's supposed to be, zero Valley. And, all of the people that you have cooperating at this level will, statedly claim that, they have zero routing policy, or they have zero Valley routing. So there's more going on here, I think, than we're aware of. This is, I don't work at a tier one. I work at a content provider. But I can see that this is happening, and I read the papers and see it's obvious, it's documented. There's way more going on here than should be happening, given what they're saying they're doing, and the mechanisms they have at their disposal to stop it from happening.
Okay. I am quite serious, though, that if you can identify places that are doing this, we can get them shut out of the routing table very easily. That's why, I mean, this is an easier problem to solve once you know consistently where those routes are coming from.
Again, I just want to say, yes, it's a BGP attack. Yes, it's big and scary. I think that we as a community have gotten ourselves here. We've gotten ourselves to the zombie problem. We've gotten ourselves to the BGP problem. And we've done that by, oh, that's easy, I can just filter X. It's a really bad attitude to have. I think that we should have, in the beginning, taken a really more critical look at this problem. And I think we should have done a better job solving it. So go ahead, sorry. Oh, God, help me, is that Brad Knowles? That's Brad Knowles?
Different guy.
Okay. I apologize in advance if I'm picking nits here, but many of my most successful delivery countermeasures aren't IP-based at all. They're things like requiring a validly formed hello. You've said delivery countermeasures generic through this. Am I to understand by that IP-based delivery countermeasures? The others are fine?
What are we talking about?
Things like requiring a valid hello, validly formed hello.
Yeah.
Those, okay. Yeah. All right. I apologize for picking nits again.
No, no worries. No worries at all. And I understand that this isn't going to be easy. Like, I'm fully cognizant of the fact that we have a very much ingrained community of people who are very much tied to their delivery countermeasures, and that their delivery countermeasures are providing them with, outstanding results, and that, a layered approach to the problem and all this good stuff. I totally recognize that. I'm really afraid of the direction it's taking us. Brad?
I was the Internet Mail Administrator for America Online from 95 to 97, and I can tell you, content scanning, it's the single most expensive thing you can do on any kind of server. And the spammers are already working around all the content filters in existence. Yes, you can train them, but then the spammers can retrain them. Content filtering does not scale, at least not in my experience.
Okay.
The other thing is, in terms of people connecting to you from bogus networks, well, that can be solved easily enough with a bogon filter. Of course, that doesn't address the problem of people popping up and misadvertising legitimate networks. There's no bogon filter that's going to catch that. I think the biggest problem, this is not Nanog. The problem you're talking about, you need to take to Nanog. You need to get the network operators caring about this, because we're doing what we can with the tools we have. The systems administrators, the mail systems administrators frequently don't work in the same office or the same building as the network admins. And I don't see a way to solve that problem.
Okay. So first, I'd really disagree with you that content filtering isn't scalable. And when I say content filtering, I'm talking about CRM114, BOGO filter, and DSpam. I'm not talking about spam filter, or sorry, what is it, spam assassin, any of these sort of Perl-based, anything that DCC, any of these that you need to talk to another entity in order to make the routing decision or anything like that. I've had, and I know people who have had amazing success with using content filters on really large networks. I'm not, who's the college here? Help me out. Who's that? Vancouver? Toronto University has a really huge BOGO filter implementation, and they do, I really can't say off the top of my head what kind of volume they do on a daily basis, but it's a lot. So I think in the same way that you have these sort of spam solutions, and the spam assassin is one of them, where you have a MX who is taking an email, sending it off to a spam processing server or array thereof, there's probably, if you have that large of an environment, some potential for you to do, offline content filtration. To get to your second point, the take it to nanog point, that it really discourages me, honestly, to hear you say that, because I really honestly feel that what we're doing here, and I know I've said it 4 or 5 times here, is incentivizing our problem to attack their problem, right? And I don't feel like this should be a toss it over the fence sort of thing. We need, as systems administrators, to handle this in a way that impacts our customers the least amount of impact that it can have. And I'm so eloquent, aren't I?
I would agree with that, but the problem is there's no way to unring this bell.
One more time, sorry.
There's no way to unring this bell. The spammers have already found out about this problem. They're going to use it.
But make it worse?
It doesn't matter. Whatever else we do, even if everyone in the universe stopped doing filtering by IP address tomorrow, the spammers would still inject through bogus IP addresses because it's just one tool out of many that they can use to help hide their networks.
I don't know. Every spam presentation I've ever been to, the speaker alludes to this sort of economics-based model for why spam happens and who it happens to. And I really feel like if there wasn't an economic incentive to do IP-based attacks or network layer attacks, that no one would do it. I mean, that's obviously opinion. I can't really back that up with anything.
But you've already pointed out the major security vulnerability here. Until the security vulnerability is addressed, it can always be exploited. And will be, even if people don't properly understand why.
But how is an IP-based attack an exploit against a content filter?
Because it helps hide the origin of the message from detection. There's no way to shut them down. You can't figure out if they really are coming from the proper owners of 12 dot or if they just advertised 12 dot for 7 minutes and then went away.
Which matters if you're filtering based on IP. But if everyone in the universe stopped, like you said, using IP as an incidental indicator, then we wouldn't care, right?
Well, no, you would care because I think this may be a discussion we need to have.
Absolutely, yeah. No, I'd love to talk to you about it. I really would. Sorry, go ahead.
Oh. I don't want to repeat a lot of the things other people have said. I mean, in a practical sense, most mail administrators will use IP-based filtering because it reduces the load on their mail servers. IP-based filtering is cheaper than doing content filtering in pretty much every instance. And content filtering is expensive no matter what you're doing. I think the real point, one other thing I would probably want to add. So a lot of people claim that there's an economic model to spamming, and to a certain extent, spammers are making money. My opinion, which may be slightly heretical, has always been that it isn't so much that spammers are making money, it's not costing them enough to spam to get them to stop. And I've actually heard this theory, I think espoused once by, it was Barry Shine, that really the diehard spammers are sociopathic. I mean, that they're doing it almost more for the ego boo than because it happens to be a money-making business for them. And so my final point is, so you're saying that you think that if we stopped doing IP-based filtering entirely and went to content filtering, that we would be removing this incentive for spammers to forge IPs, which is true, but then we would just be giving them the incentive to come up with ways to defeat content filtering, which they already are observed to be doing. Basically, spammers will try to get around any mechanism you're using to try to prevent their spam from getting through, no matter what it is. So saying that, maybe you think IP-based filtering is bad, and, it could be, that doesn't mean that stopping that and switching entirely to content filtering will make spam stop or make it get any better.
Okay. So first, you guys really need to start asking just one question. You're killing me. So first, let me say about, what was the first one? man, I had that right on the tip of my tongue. They were more comments. Why admin use IP-based filters versus content filters? My personal opinion, and again, I don't have a paper that I can footnote here. My personal opinion and my personal observation has been that we as a community are using IP-based filters because we're lazy, and because they're easier to implement, and because it's sort of an instant win.
We're using
NBCs are complicated and, sorry?
we're using IP-based filters because A, they work, and B, because they save money.
Well, 85% of the spam that's being generated is generated by zombie PCs. So ostensibly, you're getting, spam from addresses that the RBLs have never seen. And when the RBLs are adding those addresses, you're blocking people's home PCs. So, I mean, I agree that they work for now. I'm not sort of arguing their effectiveness. I'm arguing whether or not we should be using them given the context of this arms race and where we find ourselves in it, right? Can I just get to his second? I'm sorry.
Please do.
So his second question was louder. Second comment. So there is no economic model. There was, a sociopath. I can't really say anything about that, guys. They could be sociopaths for all I know. I'm sorry. Okay.
You want to replay it?
Yeah.
I think I wasn't necessarily asking you questions as much as offering some commentary, on what I thought you were, on kind of the main point you're making.
Cost.
Well, yeah, I said that it costs. My theory is that it isn't that spammers make a lot of money off of spam. It's that it costs them very little to spam.
No, in terms of CPU expense, right? So
I have numbers on what it costs us to run Spam Assassin. It's the single biggest.
I flinch when you say Spam Assassin in the same context as a content-based filter.
It's what our users want. Okay.
There are way less expensive content filters you could be using, first of all, but that's not what I wanted to say. The point I wanted to make was there is this factually stated bias against NBCs that goes, NBCs are more expensive and therefore we should use something less expensive. The thing that I think we're missing is that RBLs require a network connection. They require a network connection to an external entity that you do not control as a systems administrator. So you can't just sort of factually state that any given NBC thread is going to run faster than any given RBL thread because the RBL thread is network bound, which you can't sort of predict. One of the very first spam solutions I tried was Vipul's Razor. And the reason we had to get rid of it was just because the external entity that was in charge of it was really crappy. They just weren't good systems administrators. And it affected my mail volume. And I can't do that as a systems administrator.
For a lot of those, you can cache the data locally.
Yeah, DCC, this is true. But then you have the DCC token attacks and that kind of stuff. I like the NBCs a lot better. That's the other things. I was just trying to make a point at
On what kind of scale have you run them? Have you done millions of messages per day?
No, I personally have not done content filtering on millions per day. I
That's
could introduce
why
you to
I'm
someone
saying
who has.
they don't scale.
Sorry?
That's why I'm saying they don't scale.
Okay.
I've seen the numbers on BOGO Filter and CRM, all the others. Yes, they're lower impact than Spam Assassin. It's not by enough to make a difference. Not at scale.
Yeah, hey, there you go. Good idea. Let's do a poll. Does anybody use NBCs at that level? Because I can't help. Is anybody using naive Bayesian content filter at the level of, what was it, 1 million messages per day?
Millions of messages per day, yes.
And we're not happy?
It's not scalable.
Well, I wasn't asking.
We can throw enough machines at it because we can afford to, but
Of those who raise their hands saying they're doing it, keep your hand up if you're
There
not
you
happy
go.
with it.
I'm bad at this poll thing.
Okay, so that's 2 out of 5.
There's a lot of implementation
we also
stuff
run Spam
going
Assassin
on
on another site. Again, it doesn't scale. We're not happy with it. We're not happy with any of these learning-based systems.
Published a paper showing where they failed. One of the, I said co-author on the paper is talking about
It's wireless.
One of my biggest frustrations as the co-author on the 2004 paper is, and if you look at, you know, the field of research that's out there, no one is publishing anything to back up the assertion that these things fail. No one's giving data. It was the conclusion of our paper. If we're wrong, then show us why. We cited in that paper an ISP in Australia that is handling 1.5 million messages a day at that time with a single set of word lists for their entire user base. So people are doing it, and they were very happy with it. Their users didn't even know what they were using to filter, but they were blocking, you know, enough of their spam. They didn't need anything else.
I'm already overworked. I don't have time to write all this stuff for you.
Well,
I can tell you
might
don't
be
scale.
overworked because all these people that are saying, you know, the blacklists work for us and the other ones don't.
No, blacklists don't work either.
Well, other people are citing those as things that work. If they work, then why do we still have this problem? Why are we still chasing our tails? Why do we still have the arms race?
Because spammers are well distributed, well funded, well motivated, and there's a hell of a lot more of them than there are of us.
And we keep reacting to them, though. The bottom line to me, and the biggest frustration I have with what we as systems administrators are not doing about this problem is that, when was the last time you guys sat on a paper at LISA that cited that many papers as part of research? We talked about this last year at a LISA guru or BOF or something, just about the fact that the state of the art in systems administration research, we aren't doing research, we aren't doing, you know, we aren't challenging each other anymore. This is a great, I mean, thing going on here. He's getting grilled, but I know him, and I know he likes it.
Because we're admins, we're not researchers. We're operations guys, we're not academics.
Yes, but
at least most of us.
We're trying to solve problems. And the point I'm trying to make here is that everybody stands up and says, well, content filters have been beaten. We all know this as a fact. No, we don't. I mean, if it's true, no one's bothering to write about it. The only attacks that have been published as defeating content filters on a large scale or on a long-term scale are ones that, you know, people at Sophos who are writing the content filters managed to cook up as some crazy experiment, you know, that comes with the way to defeat that very attack. No one is demonstrating in any kind of final sense that properly implemented, rigorously defined content filters have been defeated by the spamming community. Yes, you can throw up a spam assassin with out-of-the-box settings. Yes, you can throw up some other thing and borrow somebody else. I sit on the list in the IRC groups and watch people try to implement these things, and they make the same mistakes over and over and over again. Yes, they're hard to do, but so is sitting around and spending, you know, 8 hours a week adding RBLs or, you know, content filters and all the other crap that everybody's doing. Stop there.
Sing it. I've just been told we have about 30 seconds.
I'll keep it short. And this is a technical question, so please educate me. I don't operate at the scale you do. Well, clearly, I'm one guy. BGP announcements and withdrawals. In telecom, when somebody sends a phone call through with a fake calling party number, and you need to find out where that comes from, you trace it back through the switch ports and all that kind of fun stuff. It's a pain, but you can do it. With BGP, is it at all even close to feasible, maybe this doesn't scale, to keep logs of which peer you get advertisements and withdrawals from, so that after one of these IP blocks has been identified as one of these whack-a-mole guys that popped up, you can actually follow it back to the originating ISP, or is that just, does that just not scale?
The short answer is yes, but the longer answer is no. You can track these origin changes back to a given AS. Whether or not that AS is actually the origin they originated at is a completely different subject. So one of the biggest ways you have to influence the routing protocol is this thing called AS prepend. So let's say, for example, I have a data center in Houston and one in Dallas, and I want all my traffic to go to Dallas. What I can do is I can get on my Houston router and I can prepend my own AS as many as 5 times to the front of my BGP advertisement. And so that makes it so that to everyone else on the internet, my Houston router appears farther away than my Dallas router, right? So what the malicious route injection people would do is they'd sort of abuse AS prepend to just, you know, sort of prepend a whole bunch of crappy ASs to the front of their advertisement. And it may end on the 3rd AS, it may end on the 5th. You don't really know and you can't really tell. The Nick Feemster talk that I had in my paper is a wonderful talk. He tells really great stories of all kinds of really kludgy network stuff that they see at that layer, and I highly recommend it. Stuff like 0.0.0 advertisements coming from Vietnam and what they do about it. It's good stuff.
Sorry, just one comment before you wrap up there. I used to work for a company that used to sell mail appliances to different companies to handle millions of messages a day. Bombardier, certain companies like that, 10 million messages a day. And they were able to solve the content issues with bottlenecking, most of it I/O, processor bound, stuff like that. So they were able to handle at least 1 million messages a day doing content filtering.
Thank you. I think that about covers it, guys. So, you want to take it outside?